Hello viewers, welcome to video tutorial on limitations of Bohr's atomic model and Sommerfeld elliptical model. We are very much aware that Bohr's theory is the first theory which has proposed a proper orbits for electrons in the nucleus. It proposed the electrons revolve in the circular orbits inside the atom and only those circular orbits are allowed for which angular momentum is integral multiple of h by 2 pi. But it could not explain the spectra of atoms other than hydrogen. Hydrogen is the fundamental first word atom with only one electron. For hydrogen, it could explain to some extent the spectral lines, but it could not explain the spectral lines of other atoms, higher atoms. Even in the case of hydrogen, it could not explain the fine structure, how the spectral lines split with increasing fields, it could not explain. And there are some deviations from the theory to the real-time observations of spectral lines. Also, the how the electron transit between different orbits, the transition rates or selection rules are not explained by the Bohr's model. We know that different electrons occupy in different shells. How this electronic distribution is there inside the orbits is not explained by the Bohr's model. Also, it could not explain the Zeeman and Stark effects. Zeeman effect is the splitting of spectral lines in the external magnetic field, whereas Stark effect is the splitting of spectral lines inside the external electric field. Coming to the Sommerfeld relativistic atom model, Sommerfeld modified the Bohr's model by introducing elliptical orbits in the place of circular orbits and also taking into consideration of relative mass of electron. Now let us suppose that at any instant of time the position of electron in the elliptical orbit can be denoted by radial vector r and azimuthal angle that is phi. Velocity of electron at any instant of time can be divided into two mutually perpendicular components, that is Vr and V phi. Okay. Similarly, to quantize the elliptical orbits, we require two quantum numbers. They are radial quantum number nr and azimuthal quantum number n phi. The principal quantum number n is given as summation of nr and n phi. Now, to quantize the orbits, we know that angular momentum is integral multiple of h by 2 pi. Here, as we have two components of angular momentum, radial component and azimuthal component, so we have different two different equations for radial and azimuthal component. They are integration of PR dr is equal to nRh and integration of p phi d phi is equal to n phi h. Now, to solve these equations, we first start with the angular azimuthal equation where p phi is a constant. So, we can write it outside the integral. As it is constant, we can write it outside the integration. Upon integration, we get 2 phi. So, p phi can be written as n phi h by 2 pi or simply n phi h cut. Now, in the case of radial component, we cannot directly integrate it. So, what we do here, we first convert it in terms of azimuthal components. For that, what we do, we know that we are very much aware that momentum P is equal to mv, where v can be written as dr by dt. So, momentum can be written as m times dr by dt. The same thing is written here. Here we change the variable from time to phi. So dr by dt is replaced by dr d phi times d phi by dt. Again, this d phi by dt can be replaced as d phi by dt is nothing but omega. It can be written as we know that angular momentum L is equal to mvr, and v can be written as r omega. So this can be written as mr square omega. Omega is d phi by dt. So omega is nothing but L by mr square. In our concept, L is p phi and omega is d phi by dt. So this d phi by dt can be replaced as p phi by mr square. Now on readjusting and cancelling mass m on in the two parts, numerator and denominator, we remain with dr by d phi times p phi dr square. Now we substitute this in the first quantization equation. So on substitution we get this equation. If we carefully observe this, again here we have dr, so we convert this dr into dr by d phi times d phi. Let me rub all these things. Wait a moment. So as p phi is constant, we are writing it outside the integral, and the integration of 1 by r dr by d phi whole square d phi is equal to nr times h. From the formula of ellipse, we can write 1 by r as 1 plus epsilon cos phi by a times uh, 1 minus epsilon whole square. This one. I hope it is visible. Now, on differentiation of this one, we get this equation. We get minus sign on both sides. On cancellation, we get this equation. Again, if we divide this equation, this differentiated equation, with the first one 1 by r, we get in the denominator we on the left side r square is dropped. Similarly on the right side a times 1 minus epsilon whole square will be cancelled. So we get this equation. Now let us substitute this equation in the integral. On substitution we get this equation. Here it is a standard integral whose value can be written as shown by this equation. Now if we observe there is h in every term, so we drop h, we cancel the h, and we take this minus n phi to the right side, it becomes nr plus n phi. We take reciprocal on both sides, so the equation becomes like this: 1 minus epsilon square whole power 1 by 2 is equal to n phi by n. But from the principles of ellipse, we know that 1 minus epsilon square is nothing but b by a whole square, where b is the semi-minor axis and a is the semi-major axis. So from this equation, comparing these two equations, we can write b by a is equal to n phi by n. So this is the condition for Sommerfeld elliptical orbits. From this condition, we can say that only those orbits are allowed. Only those orbits are allowed, those elliptical orbits are allowed, for which the ratio, that is b by a, is equal to n phi by n.